In the stillness of Libra, a lone star flickers, a weak, forgotten ember in the cosmic sea. To the naked eye, it appears inconspicuous. However, astronomers regard it as a riddle cloaked in starlight. They call it the Methuselah Star. And here's why it astonished the world. Early calculations suggested an age of 14.5 billion years, which is older than the universe itself. How could this be? How could a star exist before time, galaxies, or even the Big Bang as we know it? This is a voyage through primordial starlight, from the birth of the first elements to the cutting edge of space telescopes, where data and doubt collide. Because if this star truly is what it appears to be, it doesn't just rewrite astronomy, it challenges the very timeline of reality itself. Our universe is estimated to be about 13.8 billion years old, a number determined by studying the afterglow of the Big Bang and the expansion of space. Imagine astronomers' surprise when they found a star whose calculated age was greater than 13.8 billion years. Initial estimates in the early 2000s put the Methuselah Star at nearly 16 billion years old, a clear paradox. How could a star be older than the universe containing it? This wasn't fringe science or a wild theory. It was a genuine mystery born of careful observations. The star's apparent age challenged scientists to question their methods and understanding. It set the stage for a cosmic detective story. Either our age of the universe was wrong, or our understanding of this star was incomplete. To understand why Methuselah's age is so startling, we need to wind back the clock to the era of the first stars. In the infancy of the universe, after the Big Bang, there were no stars at all, just hot gas cooling over time. Eventually, the first generation of stars, known as population 3 stars, flickered into existence. These primordial stars were made almost entirely of hydrogen and helium, the only elements the early universe had in abundance. They were monsters, extremely massive and bright, and they lived fast and died young. In just a few million years, many population 3 stars exploded as supernovae, forging heavier elements, like carbon, oxygen, iron, in their violent deaths. Those explosions scattered new elements into space, seeding the cosmos with the ingredients for the next generation of stars. From the enriched debris of the earliest stars, a second generation of stars emerged. Astronomers call these population 2 stars. They are still ancient, but contain trace amounts of heavier elements. We call these elements metals in astronomy. The Methuselah Star, formerly known as HD 140283, is one of these early population 2 stars. Formed roughly 13 billion years ago, shortly after those first supernovae, it carried the chemical fingerprints of a universe that was just beginning to experiment with elements beyond hydrogen and helium. Think of population 2 stars as cosmic secondborns, younger siblings to the very first stars, but still unimaginably old by human standards. Methuselah likely lit up when the universe was only a few hundred million years old, making it a living relic from the dawn of time. How do we know Methuselah Star is so old? The clues are hidden in its light. When scientists spread out the star's light into a spectrum, much like a rainbow, they look for dark lines, signatures of elements absorbing light at specific colors. Methuselah's spectrum revealed it is extremely metal poor, meaning it has very low amounts of heavy elements. In fact, its iron content is about 250 times lower than that of our Sun. This is a telltale sign of an ancient star. Younger stars, like our Sun, a population 1 star, are born from clouds recycled through many generations of supernovae and thus have lots of heavy elements. Methuselah, with its meager metal content, could only have formed before such enrichment became common. Its light essentially whispers, "I come from an earlier universe." By studying the specific elements, like the ratio of oxygen to iron in the star, astronomers gather clues about how long the star has been burning and what materials were available when it formed. The Methuselah Star doesn't quite belong to the familiar neighborhood of younger stars in our Milky Way's disk. It's actually passing through our region of space on a long journey. Astronomers have tracked its motion for over a century and found it zips along at about 800,000 miles per hour. Over centuries, it slowly moves against the background of more distant stars. In fact, every 1,500 years or so, it travels a distance across the sky equal to the width of the full moon, an astonishing pace for a star. This unusual orbit and high-speed hint at Methuselah's origins. It likely came from the galactic halo, the extended spherical cloud of ancient stars surrounding the Milky Way. Researchers suspect Methuselah was born in a dwarf galaxy that our young Milky Way tore apart and assimilated over 12 billion years ago. The star survived that galactic cannibalism and has been on a long, looping orbit ever since. Right now, we're lucky to catch it passing relatively close to us, about 200 light-years away, offering a rare up-close glimpse of the early universe. Figuring out a star's age is one of the trickiest tasks in astronomy. We can't just look at a star and read a clock. Instead, scientists infer age from properties like brightness, color, and chemical composition. When Methuselah Star's light first suggested it was extremely old, astronomers needed more data to pin down its age. One crucial piece of the puzzle was distance. If you know how far a star is, you can determine its true brightness, how much light it really puts out, as opposed to how bright it just appears from Earth. True brightness, combined with a star's temperature and composition, lets astronomers compare the star to theoretical models of stellar aging. In 2013, using the Hubble Space Telescope, researchers measured Methuselah's distance with high precision, around 190 light-years from Earth. They used a method called parallax, observing the star's slight apparent shift in position as Earth orbits the Sun, a bit of simple trigonometry on a cosmic scale. With that refined distance, they calculated how luminous the star truly is, which in turn tightened up the age estimate. With improved measurements and advanced models, the Methuselah Star's age was revised. Instead of a wildly impossible 16 billion years, the star's age came out to about 14 billion years, give or take a few hundred million years. This was a huge relief. Taking the uncertainty into account, Methuselah could be as young as 13.7 billion years, just shy of the universe's 13.8 billion years. In other words, the paradox was essentially resolved. The star is just about as old as the universe, but not actually older. As science improved, the impossible-aged star now fits snugly at the universe's dawn, rather than before it. Some later studies even suggest Methuselah might be closer to 12 to 13 billion years old, well within the safety zone. The mystery wasn't that the universe was wrong, it was that our data were incomplete. By getting better data, scientists showed that nature still made sense. A star cannot outdate the cosmos it lives in. But it came thrillingly close, making Methuselah a record holder, one of the oldest known stars. The Methuselah Star story touched on an uncomfortable question. How confident are we in the age of the universe? Recently, the James Webb Space Telescope, JWST, has observed galaxies so distant that we see them as they were just a few 100 million years after the Big Bang. Strangely, some of these infant galaxies look more developed than expected, almost like they had too little time to form. This has led a few scientists to speculate. Could the universe be older than 13.8 billion years? One controversial idea is that the cosmos might be much older, perhaps 20+ billion years, under alternate cosmological models, which might explain these impossibly early galaxies. However, it's important to note that the mainstream scientific consensus still holds firm at 13.8 billion years. Most astronomers believe we just need to refine our understanding of galaxy formation, rather than rewrite the age of the universe. The JWST findings are a reminder that science is always probing its own assumptions. In Methuselah's case, it turned out our stellar age estimate needed tweaking. In the JWST's case, our galaxy formation theories might be what need tweaking. Either way, the Methuselah Star stands as a testament to how one discovery can make us question fundamental truths, even if only for a while. Having narrowly escaped being older than the universe, the Methuselah Star still holds invaluable lessons. It's like a living fossil from the cosmos. By studying it, astronomers glean insights into what the universe was like in its first billion years. Methuselah and other metal-poor ancient stars confirm that the first generations of stars formed quickly and that a few of their direct descendants are still around today, shining on to tell the tale. Its very existence helped set an upper bound on when the first stars could have ignited after the Big Bang, since it had to form after the first supernovae seeded heavier elements. In essence, Methuselah is a time capsule. Its atmosphere carries the imprint of primordial nucleosynthesis, and it validates our models of stellar evolution at extreme ages. As of now, Methuselah Star is in a transitional phase of its life. After billions of years as a steady hydrogen-burning star, it has begun swelling into a red giant as its core hydrogen fuel runs low. This transition is something our own sun will experience, but not for another 5 billion years or so. For Methuselah, after such an incredibly long and stable youth, old age has finally arrived. What lies ahead for the Methuselah Star in the far future? After its red giant phase, it will shed its outer layers, perhaps creating a beautiful planetary nebula for a short time. The core left behind will condense into a white dwarf, a hot, dense ember roughly the size of Earth, made mostly of carbon and oxygen. White dwarfs are essentially the final evolutionary state for stars like Methuselah and our Sun eventually. Here's the astonishing part. White dwarfs cool down incredibly slowly. In fact, the universe is not old enough for any white dwarf to have cooled into a black dwarf yet, a theoretical cold, dark star remnant. Methuselah, being one of the oldest stars, will likely be among the first candidates to reach that fate, but only in trillions upon trillions of years. Long after the Milky Way has possibly merged with other galaxies, and perhaps after stars have stopped being born, the Methuselah Star's white dwarf may fade to black. It's a poignant destiny. A star that has shone since nearly the dawn of time will become a quiet cinder in an ever-chilling universe. In a way, Methuselah's fate is the ultimate patience test. The final chapter of its story will unfold on timescales far beyond human imagination. Today, the Methuselah Star still gleams in the constellation Libra, near the border of Ophiuchus, about 7th magnitude in brightness. That means if you have a good star map and a pair of binoculars, you can actually spot this ancient traveler yourself. As you gaze at it, or simply imagine it, if you don't have the chance to see it directly, consider the journey it has been on. This star has seen the galaxy transform around it, surviving supernovae, galactic collisions, and the passage of nearly 14 billion years of time. Its story reminds us that the night sky is not a static backdrop, but a living history book of the universe. The Methuselah Star's almost paradoxical age was a humbling lesson that even our best scientific theories can be challenged, and that with persistence, we can solve those mysteries. As we end our cosmic voyage, take a moment on the next clear night to look up. Among the countless stars overhead, one of them is the Methuselah Star, the ancient guardian of cosmic memory. Its light has been traveling for almost 2 centuries to reach your eyes, but its story spans nearly the entirety of existence. If that doesn't inspire wonder, what will? Keep exploring, stay curious, and remember that out there in the darkness, the universe holds secrets we've only begun to unravel.